Today in geometry, we're going to focus on the Pythagorean Theorem and its converse. So we're going to work a lot with right triangles, and we're going to have to be able to identify sides of them. So first of all, let's start with these first couple problems by just kind of going through some vocabulary. So first of all, in the problems that we are going to look at, one of the things that we kind of have to be careful of is dealing with Pythagorean theorem. So first of all, you'll notice I've put A, B, and C on these triangles. That's a very common thing. A and B have to be the legs of the triangle. They're the ones that will form this 90-degree angle. And C is the hypotenuse, so it's the side that's across from the 90-degree angle. C is always the longest side of the triangle when you're talking about a right triangle. Now you may hear something called a Pythagorean triple in this section. A Pythagorean triple is three numbers that satisfy a squared plus b squared equals c squared. Probably the biggest example of that is a 3, 4, 5 triangle. If 3 and 4 were a, and I put them into this equation, if I were to solve it for c, c would end up being 5. Now I will tell you, because there's squared things on here, in order to be able to solve, we are going to have to use a square root. So you will see kind of that being able to simplify a square root or using perfect squares kind of idea coming up. So let's take a look at an example. So on this one, they want us to find the missing side. So first of all, you can tell this side C is the one that's missing. The 21 and the 20 would be things that we'd have to put in for A and B, because they are the two sides that make up the 90-degree angle. So 21, 20, and c squared. So 21 squared would be 441. 20 squared is 400. So those two together would give me 841. So to find just c, I would have to do the square root of that. Now the good news for us is that 841 happens to be a perfect square. And it's a perfect square of 29. Now I'm hoping that you notice that in front of the square root I didn't do a plus or minus, which we do see statistically, mathematically when we solve things. There's no plus or minus here because if C stands for the length of a side of a triangle, it has to be a positive number. So kind of keep that in mind. Now in this kind of a problem, there's a number that's in the C spot, this 20. So if I were to plug in 8 and x would have to be A and B, whichever way you want to plug them in. So if I plug them in, it would start to look something like this. Now 8 squared is 64. 20 squared is 400. Subtract 64 from both sides. Which leaves me 336. So to find x, I'm going to have to take the square root of 336. Now, lots of ways to solve this when you go to deal with this, but probably one of the easiest ones for me to see in a problem like this is that 336 breaks into 16 times 21. Now 16 is a perfect square. So if I were to separate these, 16, the square root of 16 is 4, and 21 has no perfect squares that are part of it. So this ends up being 4 times the square root of 21. Now, one of the other things that they may give you is some information about the triangle, and they'll ask you basically if it's a right triangle. So if it's a right triangle, I should be able to plug it into this. Oops. I should be able to plug it into a squared plus b squared equals c squared, and both sides should equal each other. Now in a picture like this, 85 is the longest one. So that would be my c. That means that 13 and 84 are going to have to get plugged in here. So 13 squared is 169. 84 squared is 7,056. And 85 squared would be 7225. Now, if I add these two up, both sides would be equal. So if both sides are equal, then it's a right triangle. There are also possibilities of having triangles being obtuse or acute. If it's obtuse, then the c squared has to be bigger than a squared plus b squared. In the same way, if it is acute, then the c squared has to be smaller than a squared plus b squared. So let's take a look at what this actually means with numbers. If I were looking at these as numbers 6, 11, and 14, I can see how 6 and 11 could be A and B, and 14 would be C. So let's plug these in and see what we get. So 6 squared plus 11 squared, and then 14 squared. So 16 squared is 36. 11 squared is 121. And 14 squared is 196. So if I were to add these two together, I'd end up with 157. And this side's 196. So I can see the 196 is bigger. So if c squared is larger, then that means that this has to be an obtuse triangle. Okay, let's take a look at a couple others. Okay, this one says a right triangle has legs of 16 and 30. Find the length of the hypotenuse. So really what they're telling you is you have some kind of triangle here. They're telling you it's a right triangle, so we already know that there's a 90-degree angle. And the legs are 16 and 30. And they want you to find this. So 16 squared plus 30 squared equals c squared. So 16 squared is 256. 30 squared is 900. So 256 and 900 would give me 1156. So if I want to find c, I'm going to have to do the square root of 1156. Now the good thing for us is 1156 is a perfect square. So if I put this in my calculator, it comes out exactly evenly at 34. And it says, do the lengths of these sides form a Pythagorean triple? Well, in this one, if I can put 16 and 30 in for A and B, and I get 34 out of C, then yes, it would be a triple. And if I wanted to prove it, I could actually plug these in and show that both of these sides equal the same thing. And then I know for sure that it works.